Alright, so today we're going to talk about sine functions as math models or real application problems of these trig equations. Before we do that, we're going to do a quick review of what graphing looked like and how you would write the equation if you have the graph. If this is too fast of a review, you can go back and watch a 2.8 video. But when we graphed, we said that A right here is your amplitude. And also don't forget that it was also responsible for reflecting it if it was negative. B is the change in the period. And let's assume degrees. B is going to be equal to 2 pi divided by the period. So you know what the period is. You get B by doing 2 pi divided by it. H is your horizontal shift. Left and right, so left was plus and right was minus. And K is your vertical shift. Also, this will always be your sinusoidal axis. Up is plus and down is minus. Alright, so if I'm going to use cosine here, because it tells me to, keep in mind that you could choose many, or in this case 3 cosine graphs. So you could choose this cosine, but that would be a reflected cosine. This would be a non-reflected cosine. And then lastly, this is another reflected cosine. I typically say, why make it harder than you need to? So let's do the non-reflected cosine. So I'm going to say we're going to start here and then do this cosine. Remember, cosine is the U shapes and sine are those S's. So my trig is cosine, and I chose a non-reflected one. My vertical shift, or the sinusoidal axis, is here, down 2. My horizontal shift, I start here horizontally, so that's left 5. Remember, this is why we highlight a starting place, because you have to say where you start and end according to only one cycle. That's the cycle we're choosing. My amplitude from -2, I count up 1, 2, 3, 4, 5, so the amplitude is 5. Or you could have done -2, 1, 2, 3, 4, 5 down. That should be the same. And my period, so from the distance from your starting to your ending, how long does that take total distance? So it takes 5 plus 25 more, so that's 30. And remember, we're going to assume radians now. So B is what's used in the equation. It's not the period, but B, which is 2 pi over the period. So that's 2 pi over 30, which reduces down to pi over 15. And then if you want to get the critical points, this was used more for when we were graphing, so we don't really need this, but just as a quick reminder, that's 30 divided by 4 is 7.5. And that's when we would do like 1, 2, 3, 4. We don't really need to do that right now, so I'm not going to talk very much about that, but that's what that is. Alright, so it's y equals. Come up here, do a quick reminder. Vertical shift, then the amplitude, the type of trig, the B value, the horizontal shift. So down 2, oops, no reflect, 5 amplitude for this cosine graph with a B value of pi over 15, X for radians, plus, because left, 5. Okay, so that should just be a quick review of those equations for sine and cosine. Now if we're going to apply this to a problem, a word problem, I'm going to go ahead and let you read this. So go ahead and pause it right now and read this to yourself. Okay, so you should have read this. Again, you should pause it if you need to. Read it. You have to read it. But I'm going to underline the important stuff. So it's talking about a Ferris wheel diameter is 212, and it takes 82 seconds to make a revolution. And it is 8 feet from the ground. This doesn't make sense unless you read it, so please pause it and read the problem if you haven't. If I label on my picture everything that it tells me, diameter is from one end of a circle to the other, so this is 212. It's kind of hard to note 82 seconds. I mean, you don't really see time in a graph or on a picture, so I'll just kind of show myself that a revolution takes 82 seconds. So from the time it starts, when you're back in that same position, takes 82 seconds. And lastly, it tells me that this is 8 feet from the ground. So this is the ground, and you load 8 feet from the ground. So it's like this is a little car, this is a car, whatever those are called, seating place. So let's think about a couple of important pieces of information. Diameter. First of all, diameter is from one end of the circle to the opposite. So even though I noted that this was 212, that would also mean that this is 212. So I'll go ahead and mark that. And so what that means is that if you are here, then you are not only that 212 feet, but also 8 feet. You would be 200, I'm going to call this a max height of 220 feet. So if you fell, you would fall 220 feet and hit the ground. Let's talk about if you are here. How high do you think you would be off the ground? So take a minute, do a calculation or two, and figure out what that height would be. Okay, so that height would be half of 212 is 106, so that would be this much, but then you'd still have to fall 8 feet more to be on the ground. So that's 106 plus 8 is 114. I'm just kind of thinking about things that might come up. Also, let me note really quickly, this word revolution right here, I can't think of any other reason or any other instance where it would not indicate period, because revolution means that it's gone from where it began to where it's about to begin again. That's what a revolution is. So just a quick, I mean, if you see that word, that's a pretty good indication. All right, what I like to do before I start these is I like to get myself a quick sketch of what I think this is going to look like as far as my sine and cosine graph. So if you think about what this is going to look like, first of all, if you're riding the Ferris wheel, you're never going to go below the ground. So your height will never go below 0. Your height, we said, is going to go as high as 220, and you're not going to go past even 8, really. I mean, assuming we're just talking about riding the Ferris wheel. And this is representing your height. Your y-axis is your height, and your x-axis is your time. So we also know that at 0 seconds, this sentence right here, when the Texas star is fully loaded and begins to continuously turn, you start your stopwatch. Furthermore, you are the last one to load, which means you sit down right here. You don't move any. That's really important, because if you moved to this guy, you wouldn't have a height of 8. But right here, you have not moved, and then they begin to turn continuously around. So do make sure that you're following like your starting height. We're told that our starting height is 8. You go around the circle. Okay, so at 0 seconds, we are 8 feet high. And then also at 82 seconds, we are back at 8 feet high. And if you think about what happens is, as time goes on, you go up, you hit a halfway point, you hit a high point, you start to go down, hit that halfway point, and then you go back to that beginning height. So that's why this is what we're going to call a sine or a cosine graph, actually, but a sine wave. sinusoidal wave. I don't necessarily mean it's sine, but it's a sinusoidal wave. So that's just a quick sketch. On the next page, we're going to answer some questions and get a better graph. All right, so we've talked about a couple of these things. We've said that the maximum height is 220 feet high. And what time will your stopwatch read when you get back down? So that's saying back down here, which was 82 seconds? 82 seconds. How much time elapsed for you to reach the top the second time? So this is you hitting the top the first time. This is you hitting the top the second time. Now it takes you 82 seconds. It would take you 82 seconds to get back down to the bottom, but as you can imagine, this is probably halfway, or not probably, it is for sure. So this is going to take you 82 seconds plus 41 more seconds for a final answer there of 123. Okay, I can't go back and forth on this type of application, so you might want to flip back to the front page occasionally when I'm doing this, because I'm just going to kind of go fast because we've already done a pretty good sketch, but we're going to get more exact. So if you remember, we started by saying, well, we're not going to go below the ground, and we have a height of 8 and a height of 220. Now, we also even said that that middle height is 114. That is going to become an important number, but even if you couldn't follow how I got 114, think about the sinusoidal wave. It's exactly in between your low point and your high point. So if you average these two numbers, average just like you would average a grade, add together, divide by 2, you get 114. There's a whole bunch of different ways you can do this. And that's going to be our sinusoidal axis, or our vertical shift. So I'll go ahead and put that in right here. 114 is the vertical shift. My y-axis is height. Units do become important here, so let's make sure we note that. Height in feet and time in seconds. And so we knew that at 0 seconds, we're going to be here at 8. And we also know that the period was 82. And we'll be, again, at the 8. Now, if you go back to the front page, what did it look like when we started? Well, it started at the bottom and went down and around. My horizontal shift, in this case, I don't have a horizontal shift. What I'm about to show you starts at 0. Horizontally, I don't shift any left or right. And this is a cosine graph because it's that U shape. It is an upside down U, so I've been reflected. My amplitude from 114, how much do you move to get to 220? So you can do 220 minus 114, and you should get 106. Now, a quick check you can do is 114 minus 106 should get you back down to 8, which it does. Okay, my period is 82. So let's think about the B value. We use the B value to get the equation, and we use the critical points to get the graph. Well, you're going to need to do both of those things. So let's just go ahead and get both of those things. B is 2 pi over 82, which is pi over 41. And the critical points, this is when we did, you have your starting place, and then 1, 2, 3, 4 to end it. So that was when we divided by 4. And you get 20.5. So what that means is that 1, 2, 3, and 4 is 20.5 apart. So if you do that quick addition, 0 plus 20.5 is 20.5, plus 20.5 is 41, which makes sense because half of 82 is 41, plus 20.5 is 61.5, plus 20.5, go ahead and do that quick last add. You should land back at 82. So cosine started at the bottom, then it went middle, up, middle, down. And so this is a very nice and complete cosine graph. All right, if we write the equation, I'm going to write this down right here so that you don't you can look here, but if you flip back to the front, this is the same thing that we started with. So the order goes vertical shift, did you reflect, what's the amplitude, what kind of trig, the B value, which is why we did this, and then your horizontal shift. So we have all of this information right here. So that's y equals 114. We did reflect with a amplitude of 106 in this cosine graph, whose B value is pi over 41. X for radians, minus 0, plus 0, or you don't even have to write 0. Alright, so if you're going to try to predict your height, let me scoot this back down, when time is 15. So this is why it's really important that you know if your x-axis or what your y-axis are, because what this is really saying is that time is 15. Well, time is the x-axis. So x is 15. What is y? What is your height? Well, this is why we practiced calculator work yesterday. If you know what x is and you're looking for y, you go to the table. So I don't have a calculator, or I do, but I'm going to have to do this, and you're just going to have to do this with me. You type this in to your calculator, and then make sure you're in radians, and then you look at the table. When x is 15, what is y? So that y value you should get, if you need to pause it, go ahead and pause it, but you get 70.639. Which, if you look back at your graph, that makes sense, because 15 seconds would be about here, and I can't tell you that that's going to be 70, but it seems a reasonable answer. It's in between 8 and 114. Oh, and that's the height, or feet, 70.639 feet. So when x is 75, you should get 22.886 feet. And then make sure for minutes you type in the second version, so 5 times 60. So when x is 300, we get 171.62 feet. All right. Now, question 7. How high were you when you started your stopwatch? So when you start time starts at 0. You were 8 feet high. And if you notice, when you're 8 feet high, you're about to start moving up. That's what this question is asking. Question 8. What is the value of time, t, the second time you're 100 feet off the ground? Okay, this is where it's really, really important. Even though these may seem like similar questions, they're totally different. This is saying, what is time? So time is your x. What is x when your height, or your y, is 100? So when you're given y, you go to y equals. We're going to put this into y2. Think about what that's going to do. That's going to create a horizontal, y equals is a horizontal line at 100. So you can say, well, it happened here, so whatever time that is, and that's why we have our calculator, or here. Okay, so this is what we're going to type in our calculator. y2 is 100, and if you want the second time that happens, you're not going to intersect anywhere. You're going to intersect here. Second calc intersects right here. This point is what you're trying to get for y2 equals 100. Make sure you're adjusting your window. So if you haven't looked at your graph yet, you need to go to window. Your x minimum, look at your graph. The x minimum you look at is 0. Your x max that you're seeing is 82. Your y minimum, I like to see the 0 for the y minimum, so I see that axis right there, and then go as high as 220 for y max. And your calculator should show you this exact thing. If it's not showing you this, something's not right. And then you plugged in y2 equals 100, second calc intersect to get this answer. So after you did that, you should get 63.6 0.229 seconds. If you want to be fancy and say that's 1 minute, 3.229 seconds, go for it, but that's not necessary. All right, in question 9, what is the value of time when you're 175 feet off the ground for the 5th time? For the 5th time, that's really important because if you go back to what I just said your window was, you don't know what the 5th time is. 175 is here. The window you just have shows you the first time and the second time. So you're going to have to change your X max. And you can just kind of guess, but if it takes you 82 seconds to complete one, that's going to give you, here's 175, your first answer, your second answer, 82 more seconds, so what would that be, 164, would show you a third answer and a fourth answer. You have to add 82 again in order to get the 5th answer. You don't really have to be that exact, just know that it's going to be this number at least times 3. So change your X max. You should get this answer right here, which gets you 192.502 seconds. And that's it.